Okay, for number 19, if you have a graphing calculator, you could do this by picking a number for A and arithmetizing by putting that actual number in and graphing whatever this parabola is. That's going to be really fast and simple, but a lot of people don't have that graphing calculator, and so I want to show you a solution that doesn't involve that, because you can get this without it, and it's not actually much harder. It just does require you to memorize some facts that people with graphing calculators can kind of cheat a little bit and get away with not memorizing. Other questions, they won't be so lucky. So this is not, the graphing calculator this is why this is not a good solution here, is it only works some of the time. The formula works every time. So when I look at this equation that I'm given, it reminds me of a specific version of a quadratic equation. It reminds me of the vertex form of a quadratic, okay? So the way that that vertex form is usually presented is y equals a times x minus h squared plus k. Now, one thing you probably notice right away that's really annoying is the a is in a different spot. That's entirely to confuse you. So the a that they're giving us is different from the a that's in the generic normal formula because they want us to be a little confused by it. So we just need to ignore that, and it's less about the letter that we're using and more about the position of the pieces, right? So it's kind of like when we have a line, y equals mx plus b, and they switch the slope and the y-intercept on us. It's still a line. They still behave like slopes and y-intercepts. Just because they're in a different order doesn't mean that it behaves differently. The same is true here. It's just a more complex equation. So what are we learning from this equation? Well, the most important piece to me, in most cases, is that HK is the vertex, okay? So one important piece of that is notice that there's a negative in the formula, right? X minus h squared. So what that does is very similar to when we have x-intercepts, when we factor a quadratic to find the roots, to find the zeros. We have to switch the sign, right? So it's very similar here. We're going to end up switching the sign. So in this particular case, the vertex is going to be 3, comma a. So even though that negative is there, it's kind of built into the formula. So we kind of ignore it. If it were x plus 3 squared plus a, then the vertex would be negative 3a, okay? There we would have to put the negative back because it was removed, because it's kind of like a double negative, makes a positive, and so it gets removed. But this is not the situation, so I'm crossing it out so there's no confusion. We do know that the vertex is 3a. That eliminates choice C and eliminates choice A. Okay. Now we have to think about minimum and maximum. And the key here is that a minimum and a maximum, those are just other ways of defining a vertex, right? So a parabola does this thing where it like turns, right? So that's what we think of a parabola there. And in that case, that would be a minimum at the vertex. But it could also go the opposite way and be a maximum because it opens upside down. Well, how do we know which way it opens, right? So that's really the question. Is it a minimum or a maximum? So it has to do with that value of A. If A is positive, greater than 0, then it's going to open up this way, like a smile. Think of a positive feeling makes you smile. This parabola kind of looks like a smiley face. So if A is positive, it opens up like that. If A is negative, so less than 0, it's going to be negative. A negative emotion is a frown, right? So it looks more like a frowny face. So in this case, it's clearly negative. They've removed the 1, but it's a negative 1 is my value of A. So negative 1 would be on the orange side, right? It's a frowny face. So that means we're going to have a maximum because the parabola is going to open downward. It's going to come up to a point, the vertex, and then turn right back down. And so that's what makes choice D the answer here. So if you had a graphing calculator, you could pick some number for A and graph this, and you'd see a parabola that kind of looks like this. But I do think it's genuinely better to memorize this formula because it does come up and there will be situations where a calculator won't save you. So this is kind of foolproof. So the two things to remember, the vertex is given by HK, and the smiliness or frowniness of the parabola is given by A, whether it's positive or negative. So maybe bookmark this video so you have this little formula to come back to when it comes time to study.